All right. So we're moving on to 1.2.2. And so we're gonna still work on some of our functions and do a little function investigation.
Just give me a good scare that I needed.
Yeah.
Right. So today you guys have some work to do for me. You guys are going to make a table and you're going to plot the points from that table onto a graph. So you can either do it on notebook paper if you want, or if you like to use graph paper, down on that gray bookshelf, there's a whole stack of graph paper if you want to use a piece of graph paper. All right. So we're going to look at the function f of x equals 1 over x minus 7. So I need you guys to make a table, an XY table. So you can either do it vertically or horizontally. Right. Some people like to do it this way. Some people like to do it this way, right? So it's your personal choice which way you want to do it. Just so that I can fit more stuff on this one screen, I'm gonna go vertical. Right. So when it comes to trying to figure out what values we want to plug into our table, I'm gonna tell you some values. I'm gonna look at just the 7 here, and I want to go 5 less than 7 and 5 more than 7. So what's 5 less than 7? 2. So what's the first x value I'm going to use? 2. Yep. And then you're going to keep going by ones until you go 5 over 7. What's 5 over 7? What is it? 12, right? So technically, how many numbers are you going to have for inputs? 10, right? So you're going to have 5 inputs and 5 outputs. So those x and y's are actually points on the graph, right? So then I want you guys to make don't connect your points, but I want you to plot your points, all 10 of those points on your graph. So I'm going to give you guys a few minutes to figure out your table and to get some points on there for me. It'll take a little bit. Pardon me? We're going to go 5 numbers less and 5 numbers more. You're going to start at 2 and you're going to end at 12. First number is 2. Next number would be 3. And then 4. And then until you get up to 12. Less than the 7. What's 5 less than 7? 2. Which is the first number we're starting with.
There's a lot of like, you know, a lot of stuff you look at how do you want to use it again? You know, like what did you say here? You got the PDF pulled up and you're reading. It's much easier to follow along. I really like to know that this version of these, you know, on your here and there, and that's what I track up the sequence. So those are there for you if you choose to use them. So where are we at with things that we need to do? We've got to get more like on track in the same spot. I know that for some of you, this one, some of you almost everybody has at least not three points for me. In that, like, ASAP, get that for me. And I'll give you basically get some zero. Reading, checking, flashing, those are just the six kind of questions that we'll have to do that. We want to make sure we are aware of that. There's no both of those that we want to act. And then just use that format with our page number, size, page, how far down.
And when it comes to your fractions, if you need to, you can even use your calculator to turn those into decimals if you're better with decimals than you are fractions.
I turn this into you and take pictures.
Yeah, do pictures.
And then
Yep.
just go back to your website.
Yep. Is it for previous week?
Oh, that's first week, like the first assignment.
So, yeah, so like on the lesson plans, you can click back,
Okay.
and that's the one you gotta click on. It's gotta be the assignment page for those numbers.
That would be in whenever I can. I don't really know when I'm going to be able to do that, but I want to get home.
That's fine.
So, okay. Thank you.
No problem.
I say this, I'm referring to something, that's just that. Well, how can I say that?
Mm-hmm.
What if I just said,
So your X is 2, right? So where are you gonna plug that in? Or where are you gonna plug the 2? You're gonna put the 2 in for X.
Oh, so
So
you put the 2 here and then the 3 here.
Yep.
Okay. All right. Thank you.
No problem. You're welcome.
You know when our actual grades will be in?
As fast as humanly possible.
Please take your time.
Take the 2.
No, take your time.
Listen, it can't be worse than it.
Hey, speak for yourself.
No matter how bad I did it, it's
All right. So when you guys went through on your little graph or on your table, what happened when you put in 7? What'd you guys get for your output for 7?
For what?
When you put in 7,
What do you mean when I put in 7?
when you had your X was 7, these are inputs and outputs.
I don't even know what it says.
So you had 1 over 7 minus 7. So 1 over 0. What's that equal? Is it 0 or undefined? All right, let's do a little fraction review. So when you guys are just little wee tykes and you were learning about fractions, so let's say we were playing around with 2/3, right? So your teacher sat there and she drew this little rectangle out for you. And she says, and when we're looking at fractions, we're looking at parts of the wholes, right? And she sat there and said, this 3 on the bottom is going to tell you how many equal parts you have. So you took your little rectangle, and what did you do? You divided it into 3 perfect little pieces, right? Remember this? And then you shaded 2 of them in, right? Because you have 2 of the 3, right? So you shaded this in. All right, so now let's talk about it in like, you know, legit real words. So you have a bucket, and in that bucket you have apples. And in that bucket, guess what? You have 3 apples in your bucket, but 2 of them are rotten. So this is a rotten apple, this is a rotten apple. That means this one's a good apple, right? You guys are the good apple. So now let's think about it when it comes to our 1 over 0. So if I have 1 over 0, how many apples do I have in the bucket?
0,
0. How many are rotten?
1,
1. So how many apples are in the bucket?
0.
You got 0 apples. So out of those 0 apples, 1 of them's rotten? Doesn't make sense, does it? Right? So can we ever divide by 0? No. So that would be what we call undefined. Because there's no way to define how to divide by 0, right? So if you ever come across something over 0, it is undefined, okay? So what that means on our graph then is if we go to plot, because we know like functions are continuous and they like to keep going. But when I get to where x equals 7, it's undefined. So I'll never be at 7. So what we do is we draw like a dotted line for x equals 7. And if we're talking about x equals something, we know it's going to be a vertical line. And that's all that line is telling us is it's like, we just can't be it, right? That's why we kind of put it there. So we know that we cannot be 7. And it has a special name. And that special name is called an asymptote.
A what?
Asymptote. Weird names, yep. So, yep, definition of an asymptote is something that you can get really, really, really close to, but you can never be. Which we found out we can never be 7 because it's undefined. So we can get really, really close to 7, but we can never be 7. How many of you guys wish you could go back and be 7 again? All right, no. All right. So we know that when it comes to our functions, functions are continuously, we graph them continuously. So there's a way that we have to be able to connect our dots, but we have to be aware of that asymptote. So when we kind of plotted ours, oops, we can kind of see here like they kind of start to go up, right? So when it comes to graphing where our asymptotes are, our function's going to go this way and it's going to get really, really close to that asymptote, but guess what it can never do? It can never touch it and it can never cross it. So we know we got to go in this way and then come in this way. We're going to get close to that asymptote, but we're just never going to touch it. But it's going to keep going and it's going to get closer and 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 closer to that 7, but it can never be 7. And guess what's going to happen on this other side? We start following these. Yep, it gets close and it starts to go down. So that means it's going to get close and it's going to keep getting closer and closer and closer and closer and closer, but it's never going to touch. And because in the real world, we can never draw these things perfect, right? And that's kind of the other reason why we put that dotted line there, is so that it shows us like we're getting close to, but we can never be it. And it still follows, yes.
You can finish teaching yours, however personally you help.
All right. So if we remember when it came to testing for functions, remember passing that vertical line test where it can only cross the graph once? If I go through here, I'm only hitting it once. I'm only hitting it once. And even when I get closer and closer to that asymptote, even though it kind of looks like that line, it's still getting closer to 7. So it's always going to pass the vertical line test because it's always getting just a little bit closer and a little bit closer and a little bit closer. All right. So when it comes to functions, Our ultimate goal is to be able to represent functions 3 different ways. Okay. So one way we can represent them is a, what's this thing called? Starts with an E. An equation, right? Another way we can represent them is by using a table. And a lot of times in our book, they denote it by an XY table, right? And what's the third way we can write a function? We can make a graph. So one of our ultimate goals this whole entire year or semester is when it comes to functions and all these different families of functions is to be able to represent them by an equation, a table, and a graph. Not too bad? All right, so I got another one for you. So last week we were talking about finding intersections. And it even showed up on your quiz, didn't it? About finding intersections.
That was easy.
It was easy? It can be easy, right? And I'm gonna make this up and it's probably never, and it never works out, but let's say we have y equals 2x squared plus 6x minus 3. And let's say we have y equals x squared minus 5x plus 4. Okay. So when we talk about intersections, if you think of a line or a graph, right, you got 2 little lines, and they're going to, if we're talking about intersections, we're trying to find out where they cross. Where would 2 lines cross? What would that special thing be called? Well, yeah, it's the intersection, right? So say you got this line and you got this line. What's that little thing right there called? Starts with the P. A point. Yes, it's a point, right? 2 lines always intersect at a point. So we have to find a point. And how do we write points? That XY coordinate, right? So we're trying to find the XY coordinate of where those 2 functions intersect. So last week when we did these, we used our fancy dancy little graphing calculator, right? All right, yep. So we ultimately, oops, find my mouse here. We went to Desmos.
Can we do that on the homework and like not show what we do?
You would just kind of give me like a rough drawing of like your graph, just so, yeah, yep. So what do we have? So we had what, y equals 2x, use our little caret for the square, plus 6x minus 3. And then we had another line, y equals x squared minus 5x plus 4. Whew, it does cross, thank goodness, right? So we looked at our graphs, and then when we looked at our graphs, we tried to find that little point of intersection, right? Nice and easy kind of way to do it. But in the real world, when we use these in our everyday life, we don't always have a graphing calculator in our back pocket just to be able to plug in the equations and then, or the functions, and then be able to find out where they intersect. You never know, but right. But we also sit there and we like to have more than one option on how to do things, right? Because not all of us like to do things all the same way. So there is another way that you can solve these. Absolutely, good job. Right. Yeah, right. It's ultimately by using substitution, right? You got y equals and y equals. So we know that these 2 are equal to each other, right? Or if you think of like substitution, y equals y, so you're just plugging these in. So ultimately we would have, what, 2x squared plus 6x minus 3. equals x squared minus 5x plus 4. All right. So really our ultimate goal is to get x all by itself so we can figure out what our x is to plug in to get our y. But anytime we have a quadratic, we know we can solve quadratics by factoring them or by using the quadratic formula. That's where we're at right now, are those two ways of solving it. So in order to either factor it or to use the quadratic formula, we have to get everything on one side of the equal sign, right? Well, yep, but we gotta first get everything on the same side before we can factor it. So do you want to move everything to the left or move everything to the right?
Why the left?
I like the left. Yep. So let's start moving things to the left. So what do you want to move first?
The x squared.
The x squared. So we're going to subtract it from both sides, right? We're going to have what? X squared plus 6x minus 3 equals negative 5x plus 4. Just going step by step. Once you get a little proficient with these, you can kind of do them, you know, more than one step.
How do you do that?
Do what? Change color?
No. Alright, never mind.
Like the more than one step?
Yeah.
So like I would look at it, I'm like, all right, I know that I have to subtract the x squared. So then I would, you know, subtract it and I get the x squared. And that's all I would write. And then I'd be like, oh, I need to add 5x. And then I would add the 5x. I know I need to subtract the 4. And then I
Oh,
just
you go to subtract, oh no, I did, I thought you just subtract it like from one equation, like.
got it. Yep. So what are we gonna do next? Add 5x to both sides, right? What are we done to now? X squared plus 11x minus 3 equals 4. And then we're gonna subtract 4 from both sides, right? X squared plus 11x minus 7 equals 0. So I'm gonna slide this up a little bit for you guys. Hold on, give me a second. It's gotta kick the. Well, once I took everything away, because like right here I had it where it equaled 4, but then I subtracted 4. So what's 4 minus 4? That's gonna give us our 0. So now we can try and factor it, or we gotta use the quadratic formula. Could we factor it? Right, so to factor a times c, negative 7, right? So we have to multiply to get negative 7, but when we add them together, we get 11. There's only one way to multiply to get 7, and that's 1 and 7. And is there any way to make that 11? No. So that's how you know that you can't factor it. So if you can't factor it, you get to use the fancy dancy handy dandy
The Xbox thing.
that would be the factor, the quadratic formula. Yep.
Is that a 1 in front of the parentheses? Like the bottom?
Oh, this guy?
Or is that also 11x?
Oh, 11x. Yep, sorry. There. So what's the quadratic formula? X equals negative b plus or minus of b squared. Yep. All over 2a. Excellent. Yep. And then we'll just throw it down here. Ooh, look at that. Oh yeah, that's pretty slick. What's my a gonna equal? What's right here? What's in front of the x squared? It's invisible, but it's there. Yeah, there's technically a 1 there, right? What's my b gonna equal? Oh, well, right, 11, right? And what's my c gonna equal? Negative 7, yep. So now we can plug that into our quadratic formula, right? Nice. All right, you guys ready? Did you guys figure this all out?
Yeah.
All right, so x equals negative b, negative 11 plus or minus square root. What's b squared gonna give us? 121 minus, no, no. So 4 times A, 4 times 1 is 4. 4,
28.
yep, negative 28. And it's a negative, so it's going to make it a positive 28 all over 2. Now when we're down to x equals negative 11 plus or minus the square root of, we figured that one out, 97. Can't be a 7. Uh-oh.
It's 9.84.
I don't want a decimal, I want the whole number.
Well, that sounds like
I don't think
a,
97.
should pick different numbers.
93? Is that what it is?
149.
149. Oh my goodness, we are adding, aren't we?
Oh.
Wow, I did the same thing. Sorry, bub. That's why we got Michaela around, right? 149, right?
Gives you 12.2.
I don't want approximates. I gotta have exactness.
Okay, 12.206.
That's not, no, you're still approximating, yep. So we either try and break it down or we leave it the way that it is, right? Like this one's like a crazy problem because like I said, remember we made up our functions as we went, so we knew they probably wouldn't work out perfectly. But let's just say for poops and giggles, you go through a problem, right? See, this is you going through the problem. And then you get an answer that is like x equals, give me a nice, easy whole number. 7, right? So let's say you get x equals 7. We still need that coordinate point, so you got to have the x and the y. So remember at the very beginning we had y equaled, I don't even know what it was, like x squared minus 5x plus 3.
Almost, it was 6x.
6x?
It was plus.
This is plus and this is a 6, right? So once you get to that point, because you have your x, you still need to figure out what your y is. So guess what you're going to do with this 7? You're going to plug it into x. Right, and then you're going to get a y equals.
49 plus 42 plus 3.
Yep. What's that going to give us? Well, let's try it, right? 49 and 52.
That would be 91.
91 plus 3, y is going to be
94.
94, right? So where do they intersect? They would intersect at the point 7, 94. Does that make a little bit of sense-ish?
I have no idea where you just went.
I didn't even know what we just learned.
You just told us to make up a random number.
Yeah, we did, right? But how would you get the y? Once you found out x, we know how to get x. You're either going to factor it or use the quadratic formula. But you still have to get the y value. So how do you figure out the y value?
Should we finish them?
You plug it back into the problem. Does that work? All right.
Should we finish the quadratic formula?
Yeah. Hold on. So you guys have, we'll go back to that one in just a second. Let me get you guys started on your homework for those. So if you guys go to the website, right, and go under today, it'll give you guys a couple problems to do.